This is lesson 2.4, writing linear equations. So the slope-intercept form of a linear function is in the form y equals mx plus b. So we talked about that the other day. The most important spots of this is the m is the slope and b is the y-intercept. So the y-intercept is your beginning point on the y-axis. So you're going to plot a point on the y-axis to start. And then the slope, the m, is how you're going to move. So remember, that's rise over run. So that's how you're going to move to find your next few points to make your line. So we'll talk about a few of those here in the next slide. We're going to match up the lines with the equations on the choices on the left. So you can see some of the y-intercepts are at the end. It's either a half, positive 2, negative 2. So that's something to look for first. You have some positive or negative m's. So we're just going to have to figure out which one goes where. So this first one has an intercept of a negative 2. And the rise is 2. And the run is 1, 2, 3, 4. So the rise was 2, the run was 4. This has a slope of 2/4 for the m, or a half. So it has the equation y equals 1/2 x minus 2. So that's this one right here. This next one has a positive y-intercept of 2, and its slope is going up 1 and over 2, and it's slanted in the negative direction. So your m is a negative 1/2 here. So you have the equation y equals negative 1/2 x plus 2. So that's the second one. The third graph has a negative 2 intercept. And if we find another crossing point, it's up here. So that's a rise of 1, 2, 3, 4 over 1. So a rise of 4 over 1, that has a slope of 4. So we're going to have y equals 4x minus 2, which is right here. On the bottom, this one has a negative 2 intercept, so that's going to be the minus 2 at the end. The slope to get to this point here would be a rise 1, 2, 3. Run 2, so that's a 3 over 2, and it's slanted negatively, so that's your m, so negative 3/2 x. So that's this last one. And you can see, obviously, this one has an intercept of a half. There's two equations that have that, either a positive 2 or a positive 4 slope. So let's see here. We're going to go up 1. Let's see if we go up 1, 2. So if I go to the middle here, that's a rise of 2 and a run of 1. So this is going to be y equals 2x plus a half. Yeah, 4 is too steep for that one. And then the last one we have is a positive 2 at the end, the intercept. And if you go to this point, that's a rise of 2, run of 3. So the slope is 2/3. So y equals 2/3 x plus 2. So there is one that we didn't use there. All right, next up. Now we're going to write an equation in slope-intercept form for the line being described. So y equals mx plus b. It gives us the slope, so this is the m, and it passes through the point 0, 4. So anytime you see 0 in a number, that's like the 0 and the b values right there. That is your y-intercept already. So our equation, we just have to put it all together. Y equals 4/3 for the m, x plus 4 for the y-intercept, for the b part. Notice on 1b, they don't tell me the slope right away, so I need to find the slope first. Remember we talked about that yesterday, I believe. y2 minus y1 over x2 minus x1. So we'll call this x1, y1, x2, y2. So this is going to be 10 minus a negative 6 at the top, negative 4 minus 0 underneath. The two negatives in a row make a positive, so this is 6, and negative 4 underneath. So that actually is a slope of negative 4 if you divide that out. Then you need to think, are either one of these points the y-intercept? And this 0, negative 6 is your y-intercept. So the b is going to be a negative 6. So if you put it all together, you get y equals negative 4x minus 6. All right, so let's do some practice problems. Write an equation in slope-intercept form for the line described. So we have the slope, here is the m, this 5 is the b. So this one is nice and easy, we just put it all together. Y equals 1/2 x plus 5. Same for this one, number 2, but we have to find the slope first on that one. So we're going to take 1 minus 3 and 0 minus a negative 2. So this is a plus 2 at the bottom. This is a negative 2 over a positive 2, which is a negative 1. So m is negative 1. And this point here means the b value is a positive 1. So your equation is going to be y equals negative x plus 1 for this one. All right, 3 and 4, now they give us 1 point and they give us the m. So they don't have us knowing what the b value is, the y-intercept is right away. But we know that the 3, 5 creates an xy point, and we know m is negative 2. So we can substitute into y equals mx plus b everything that we know and then find b. So this I don't know yet. So I know the y value is a 5. I know the m value is a negative 2. I know the x is a 3. So substitute all those numbers in, and we're going to look for b. So this is 5 equals negative 6 plus b. You're going to add 6 to both sides, and b is 11. So with that said, we got m is negative 2. We have b is 11. So we can use that information to write our equation. Y equals negative 2x plus 11. And the last one on this page, same thing. This is x, this is y, this is m. So y equals mx plus b. Y is a negative 2. M is a 5/2. X is a negative 8. Plus b. We're going to solve this for b. Some quick test here. 2 divides into negative 8, negative 4 times. So 5 times negative 4 is a negative 20. Add 20. Negative 2 plus 20 gives you a b value of 18. So if you have m is 5/2, the b is 18. If you put that together, you get y equals 5/2 x plus 18 for your equation. All right, now we have another form called point-slope form. So this is helpful when they give you a point and a slope. It's y minus y1 equals m x minus x1. And the spots that you replace with numbers are the m and the point that they give you, the x1 and the y1. The other x and m without the subscripts kind of stay in the equation. So write an equation in slope-intercept form for the line that has the slope of negative 3/5 and passes through that point. So we're going to start in point-slope form. This is m. And then we'll take that from slope-intercept form, or point-slope form to slope-intercept form. So we have y minus y1, which is the -2. Then we have m, -3/5, x minus x1, so that's the 5. And I want to simplify this a little bit. So these two negatives make it plus, so this is y plus 2 equals -3/5, x minus 5. Remember, my goal is to get it in y equals mx plus b form. So on the right side, we're going to distribute. So this is going to be y plus 2, -3/5 x. -3/5 of -5 is a +3. And then all we're going to do is subtract 2 from both sides. So this is going to be y equals -3/5 x plus a 1. So now we're in slope-intercept form. I got my m and I got my b. So sometimes it's easier, depending on what you're being asked to do. If they give you a point and a slope, use point slope. If they give you the point and the y-intercept, or the slope and the y-intercept, that's when you want to use slope-intercept form. Or just make sure you read the directions on like what form they want. The easiest way to graph is when it's in y equals mx plus b though. So you have the beginning point and the movement with the slope. So this says, what is the equation of the line? And it starts with 2 points. So each equation needs the slope first. So we got to find the slope and then write the equation. So to find the slope, remember that's y2 minus y1. We'll call this the first point, x1, y1. The second point, x2, y2. So y2 is a 7, y1 was a -3. x2 was a -3 minus x1, which was a 2. So this changes to 7 plus 3, or a 10. And the bottom is a -5. So this is a -2 slope. So m is -2. So now I need equation. So it doesn't really say what form. Let's use point slope form since I have the slope and I can use this point up here. So that's in this form. Y minus, now if you use the point 2, -3, then you're going to put a -3 in for the y1. The m was a -2. The x was a +2. And let's just clean this up a bit. These two negatives over here make a +3. Minus 2. So that's point slope form. If you wanted to go to a slope intercept, you would distribute the -2 on the right and subtract the 3 over. But we'll just keep it like that because they didn't really specify, so your choice. And the last topic is parallel and perpendicular lines. So slopes can help you determine whether the lines are parallel or perpendicular. So parallel, remember those are two lines that never meet. They have a lot in common, but they're never going to meet. So these have the same slope. So that is key. So you can see both the slope numbers, the m, are both 2. The perpendicular lines have opposite reciprocal slopes, and I'll tell you what that means here in a second. So this one had a slope of 3, and over here it was the opposite. So one's positive, one's negative, and it's the reciprocal, so you have to flip the fraction. So 3 and -1/3 are opposite reciprocals, because when two perpendicular lines meet, they form a right angle there. So one slope has to be positive and the other negative for them to cross. So we're going to do one example here. Write an equation in slope-intercept form. So they want it in y equals mx plus b form. It's always important to write the form down that they want. For the line that passes through this point, so this is our xy point, and it's perpendicular to the line that has this equation. So perpendicular means it's going to have an opposite reciprocal to -5. So that upside down t, by the way, means perpendicular. Slope is the opposite reciprocal. I'll just do OR for short. So the opposite reciprocal to a -5 is a positive 1/5. So that's the slope we're going to use on our new line. So I know the y value is a -2 from my ordered pair. I know the m value now I have to use is a 1/5. I know the x from the ordered pair was a 3, and I want to find b. So this is -2, 3/5 plus b. We're going to subtract 3/5 from both sides. And this gives you b equals -13/5. So the equation is y equals 1/5 x minus 13/5. All right, looking at the time here, I mean, this video was kind of on the longer side, so maybe you can think about this question and narrow your choices down and see which graph, which equation matches this graph, and we'll talk about that tomorrow.